Hello, good afternoon, everyone. All right. Good afternoon and welcome to the second webinar of a four-part series brought to you by NERC and NMOA as part of an EPA-funded project. The project focuses on anaerobic digestion regulation and environmental justice. It's meant to support state and local government programs that seek to use anaerobic digestion to increase their food waste diversion rates through the development of guidance and training on environmental justice engagement and regulatory compliance. And as part of this project, we're going to have 3 published materials. One is a regulatory guide, one is best practices for community engagement, and one is what is AD, how can I get involved? And that's a roadmap. So we look forward to sharing all of those with you. The webinar today is focused on citing considerations for anaerobic digesters. I'm Megan Schultz-Fontes, Executive Director of Northeast Recycling Council, or as many of you know it, NERC. Before we get started, I'd like to review some housekeeping details. Please note that this webinar is being recorded, and a recording of the webinar and a copy of presentations and the resource list will be available on the NERC website, and you will receive an email with a link. They will also be available on NMOA's website. Please use the chat to ask any questions for the presenters, which we'll get to once everyone is finished speaking. Lastly, you will receive a brief survey after the webinar, and if you could please complete this, it will help us assess the impact of the event. We have 2 wonderful presenters this afternoon from Tetra Tech. The first is Deborah Darby, True Advisor, Organic Sustainability Solutions, who serves on the steering committee for the grant project. And then we'll hear from her colleague, Peter Clausen, Senior Waste Consultant. Deborah Darby is a client manager with 16 years of experience in organics and the solid waste industry. She leads Tetra Tech's Organics Management Initiative in Tetra Tech's Solid Waste East region. She is a U.S. Composting Council certified professional. Deborah has garnered a reputation as a leader in her field through extensive background working with organics and compostable materials, assisting clients with designing and implementing organics management and infrastructure, including composting and anaerobic digestion systems. She has 25 years of experience in environmental marketing and has served as a strategic advisor in the public and private sectors. Peter Clausen is the Vice President for Tetra Tech's Solid Waste Management Practice in Ontario and Manitoba. He is a senior environmental professional with more than 28 years of solid waste experience undertaking projects in Canada, the United States, the Caribbean, North Africa, the Middle East, and Central Asia. Peter has a variety of experience in many aspects of waste management, including system design, waste management planning, environmental assessment, waste management engineering, financial and pro forma analysis, including capital, operational, and cash flow projections, assembly of terms of reference, tenders, contracts, and negotiations for both private and government clients. We're very excited to hear from Deborah and Peter today. And with that, I will kick it off to Deborah.
Megan, thank you so very much for having us present today. And I know we have, if you will, limited time. We've got 30 minutes for our presentation and then 30 minutes for Q&A. So let me just kind of jump in a little bit here. The agenda we're going to cover, just, highlight some regulatory information, talk a little bit about anaerobic digestion technologies, and then Peter is going to, really give a little deeper dive into the citing considerations, which I think is very applicable to today's webinar, citing considerations for anaerobic digesters. And just wanted to give a, let me just advance the slides. There we go. Tetra Tech, I hope everybody is familiar with who we are, but we are a team of planners, engineers, designers, and environmental specialists with the resources to address the wide-ranging needs of municipal solid waste and energy waste management markets. Tetra Tech covers the wide needs of solid waste solutions, and I just highlighted for us today where Peter and I were very involved with the organics infrastructure planning and design and construction oversight. Well, I always like to start off with, organics management and waste reduction, because we all talk about solid waste as a resource and the need for diverting materials that can provide beneficial reuse and renewable products back into the market. And certainly when we talk about composting and anaerobic digestion, there's a lot of interesting renewable products that can be brought back into the market and the development of end markets. And certainly we're familiar with compost, biofuels, and energy, but there's also the potential for renewable green chemistries, and in particular, some bioplastics. So as we make this shift to a more circular infrastructure, organics is certainly the next solid waste commodity. In last October, the EPA shifted from a food waste hierarchy to this wasted food scale, and certainly food waste prevention, rescue, and reuse are still very important. But today we are going to focus on that sliver of the scale here regarding anaerobic digestion and beneficial use of digestate as well as the biosolids. But today's focus really is on the capturing of the biogas for beneficial use. EPA also released a couple of reports last year, the draft national strategy for reducing food waste, as well as the quantifying methane emissions from landfill. And I like to bring this up because the objective is to accelerate the prevention of food loss and food waste and to recycle organics across the entire supply chain, because wasted food is linked with climate change, and we can make the point that there is insufficient organics infrastructure and planning that's needed to address our national recycling goal, which is 50 by 30. That in that chart there, reduce food waste by 50% per capita across the supply chain. And I think as more states and local government begin their planning process and look at materials management, organics certainly is a primary material for managing and developing infrastructure. And as we look at quantifying the methane emissions, we know that organics makes up 50% of the municipal solid waste stream, and the EPA reports that food waste alone is 24% of MSW that's disposed or trapped in landfills. EPA does report that 58% of fugitive methane emissions are from landfilled food waste. And keeping food waste, organics out of landfill does help reduce emission. And when we talk about organics management, we really are talking about climate mitigation. And the environmental impacts of methane is pretty significant, being 25 times greater than CO2 release into the atmosphere. So it's important that we have these conversations and look at how we can manage organics and develop infrastructure for beneficial reuse of a very valuable material. And then just quickly, I always like to talk about environmental justice. There's certainly a lot of states throughout the Northeast that have implemented environmental justice laws, policies, and regulations. And the Northeast is really leading in that space. And federally, a lot of grants have been issued last year, in particular the Solid Waste Infrastructure for Recycling grant that is helping states and municipalities focus on materials management planning and supporting organics infrastructure. But I also like to call out that the Justice 40 initiative, this is a law and a policy that helps to direct 40% of overall benefits of certain federal investments and grants, including but not limited to clean energy, energy efficiency, remediation of legacy pollution, and clean water infrastructure. And this is to benefit disadvantaged communities or overburdened communities. So again, as we look for siting of organics infrastructure, the environmental justice lens is really an important component of this. And a lot of states have been pivoting towards organics bans and diversion mandates. And just real quick here, the states in green, of course, show the organics diversion from landfill, and other states in that light orange color are the yard waste bans from landfill. And then a couple of key cities as well as counties have food waste bans. So we're starting to see more of the country looking to pivot for managing organics to from diversion from landfill and looking for ways to manage that, again, with a climate mitigation organizing us to think about this. So why anaerobic digestion for organics management? Really, a lot of the key drivers are regulatory, financial, feedstocks, and identifying end markets for the products that are coming from renewable. Other factors specific to the Northeast, we are experiencing limited disposal capacity, landfill closures, waste to energy facility closures, and that's forcing us to move or transport our municipal solid waste even further west or to the south. And when we talk about organics management, the disposal costs and the distance for moving that wet material really doesn't make financial or environmental sense. So when we think about source separation of material categories, specifically with organics and the educational components, the collection programs and the potential additional carts and in labor that's needed, we really need to think about how to maybe regionalize or more localize how to process our materials. And anaerobic digestion not only brings that processing capacity, but also introduces end markets around renewable energy. And Peter will go into more detail on that particular component. Just a real quick highlight here, looking at at the federal level, some of the regulatory environment and overview, looking at air, solid waste, leachate or stormwater management, and land application of the digestate from the anaerobic digestion process, and environmental justice. So when you look across at all of these permitting or regulatory requirements, it can be a heavy lift. In particular, the complexities of the air permitting can be a long and a process where it makes a lot of sense to work with a consulting or an expert on Title V permitting. Also with the other regulatory environments. And I'm going to just skip and go right to the environmental justice, because as we look at the federal actions and at state level, early public participation strategies are very important, because you can get through the hurdles of all the other regulatory and permitting, but when you get to the public hearing process and engaging with the neighbors or the community, if they say no, we don't want your project in our neighborhood, that's really going to shut your project down. So this is a very important component about building trust and bringing the community involved in the conversation and in the planning process. And just for you folks in the audience, just a quick tool here. This slide here just has links to states that have EJ mapping tools, and that can help with, if you will, the planning or the siting consideration, taking a look at the types of communities, businesses, and what an area might look like. And as Megan said at the top of our webinar today, with the new regulatory guide that is coming out from NUMOA and NERC, according to EPA, there are at least 71 anaerobic digestion facilities accepting food waste located throughout the Northeast. And certainly this recent expansion in AD food waste processing is due in part to state environmental agencies that support the development of renewable energy. So we're really sitting, I'll just say, kind of leading by example here in the Northeast. And the work that NUMO and NERC have put together into these guides is very helpful for informing AD developers on, if you will, the baseline understanding of the regulations with throughout the 11 Northeast states, providing some basic information again on air, water, solid waste, and environmental justice permitting requirements for new construction of anaerobic digestion facilities. And this guide serves the purpose of helping to garner, a baseline again of the requirements, but providing, I don't know, just kind of providing, the guidelines and the milestones that you might need to focus on when working with state and local municipalities. So you'll be wanting to check this one out. And before I toss the presentation over to Peter, I always like to kind of set the stage and provide an example or as an option. So let's say if people here in the audience, if they're landfill operators, and I can't see a show of hands, unfortunately. When we talk about organics diversion, landfill operators at first, it's like, I don't want to lose control of all that tonnage, that portion of the municipal solid waste coming into my landfill. What am I going to do if I lose that tonnage, that organics fraction? So one option is to think about co-locating of a wet anaerobic digestion at your landfill facility. And this slide here, we're just going to look at 100 tons per day of food waste, your initial capital costs for building a facility between 30 and $40 million in capital expense. And once you're up and running, you might be looking at around $1 to $1.8 million per year in operating expense. So over a 20-year period, your operational costs around 81 million. And if you're taking a tip fee of $50 per ton of organics, over that 20-year period, you're going to generate revenue around 88 million, and that does not include the potential biogas revenue that you might be seeing. So there's an additional benefit here if you've got an existing gas utilization project, or if you're considering the creation of a new standalone anaerobic digestion. The point here is you're not going to lose that tonnage if you can pivot to bringing in an organics processing facility as part of your solid waste campus, as part of your existing facility. And I think these numbers here are really intended just to show you that you're not going to lose on your investment. The important thing to consider, though, is you have to think about the specifics of your facility, the site design, road access, utilities, the type of feedstocks, your receptors, and how managing the organics will be driven by the regulatory environment. And my last item that I want to present is the environmental benefits. The reason that biogas is so valuable is that it has the less carbon intensity, and it generates that environmental benefit of pulling, if you will, food waste, pulling carbon out of the environment. When you compare that to the production of gasoline or diesel, it's certainly the environmental benefits of being, if you will, a negative 50 on the carbon intensity scale provides a very positive environmental impact. So I am going to now turn this over to Peter Clausen, and he's going to take us into a more in-depth discussion.
Thanks, Deborah. So first of all, I want to say welcome to everybody. It's a pleasure to be participating in this conference. But what I will do, because I have limited bandwidth, I'm going to stop my video so that the focus will be on the presentation itself. So my section of this presentation is going to be on key siting considerations. And I've kind of broken it down into 5 different aspects. So the first one, which is really important, is what Deborah has been going through, and that's the policy and regulatory aspects that predominantly come from the federal, state, and municipal governments. If you don't have sort of the benefits of these groups, or if you have problems from them, it's going to be difficult to put in a project. I'll also talk about the waste characteristics because as you hopefully I'll be able to explain, the type of waste you bring in and its respective sources has an impact on the technology and potential implementation of any AD system. Equally important is the type of technology you use, and I'll talk more about the technologies, and I'll spend a fair amount of time talking about the location because the location is going to be extremely important. That's what this is really about. And finally, I'll talk about the financial outcomes. So how does the CapEx, OpEx, and potential revenues from an AD operation have an impact on the overall project? So next, yeah. So this is an EPA diagram showing kind of where the type of organic materials come from. I know there's a focus on food waste, but when we talk about AD facilities, that the organic components can come from any one of these 4 different categories. So we'll talk about agricultural waste or manure, wastewater biosolids, basically from wastewater treatment plants. We talk about food waste, and food waste can be what's generated from the curbside, from the people themselves, or from commercial establishments like restaurants and cafeterias. And then there can be other organic compounds or other organic sources that come from industrial applications. And finally, thanks, Deborah. I just want to emphasize that there's a new stream of waste, organic waste, potentially from mixed waste, basically taking garbage and extracting the organic components as well as you can, typically through dirty MRF, and then doing something through an anaerobic digestion with that. But if you look in the bottom, you'll see there's 2 aspects of this. There's 2 kind of products. And one of them is the biogas. And what do you do with the biogas? So it can be used for heating. It can be used as RNG into the network, the gas network, or it can be used basically to generate power. And on the other side, you're also creating a digestate. So once you've extracted some of the carbon that is in the organic materials, you're left with a carbonous compound, which then can be used for things like fertilizer, carbon supplement for agricultural applications, and other products, actually, real products. So next slide. So basically, from a technology perspective, there are kind of 3 different types of technologies. There are others, and some of them have been tested, some of them have not been tested. But I'd say most of the AD facilities that are in existence in, we'll say, the Canada and the US are dry AD, and there's typically 2 types. One is a garage style, and then the other one is a plug flow digester. Wet AD, which we have a lot of experience in, and typically coming from the wastewater treatment industry. Related to that is the fact that you have to have a mechanism to, I'll call it, clean the waste. And you either do it in the front end, which is what we call pre-processing, or in the back end, which is the post-processing. And you'll see that certain technologies, it's better to have the cleaning of the waste in the front end. In some cases, you don't need to do that. You can do it in the back end. But if you don't have a proper depackaging process, the system may fail. And we've seen a few cases throughout Canada and US where it has failed. Next slide. So I'll talk now about the anaerobic digestion component of dry technologies, the garage style and the plug flow. So the garage style is basically a process where you have a chamber, and in that chamber you allow the organics to decompose. You produce a gas, which is basically goes into some type of a storage area, and you're left with basically some gas coming off of it, or gas coming off of it, and you extract that gas, and then it goes on to be either cleaned or whatever you want to do with that gas. Plug flow digesters are a little bit more sophisticated. They basically take the waste, it goes through typically a chamber where it churns it. You may add back moisture if you have moisture being extracted. And again, it generates gas. In both cases, you're looking at approximately like a 20 to 30 day of processing in order for you to be able to extract the maximum amount of gas from it. Where these are used more is where you have high solids. So this can be anywhere from 20 to 50% of the total amount of material. And you'll see on the other end, you have the wet digestion, which typically you're looking at a lower solid content. Now, what's the benefit of these two types of processes? It has an impact on transport cost, and in that case, it can be in both the front end and the back end. It also allows a greater, call it, amount of type of material that you can bring into the facility. And I'll explain a little bit more about that later. And typically these two processes have a higher capex or a higher capital cost than the wet digestion. Next slide. So wet digestion is basically, I'll say they've learned their lesson in wastewater treatment plants. It basically has a pre-processing component where you try to remove as much contaminant in the front end as possible. And then it goes into a digester, and within that digester, you're creating the biogas. Typically, you're looking at the slurry that you have is less than 15% total solids, which means that if you want to go with wet digestion, you may want to add water if you have a very dry feed. What we're finding, and we've done, I'd say in the last, let's say 2 years, I've personally been involved with over a dozen projects, and we're starting to learn from this. And that's why I'm saying the type of feed we're seeing has a significant impact on the type of technology that you use. So wet digestion, you typically don't want to include yard waste to any great extent. And you want to basically focus on food waste and biosolids from wastewater treatment plants, in which is what I'm talking about below, where you have co-digestion. What you're also seeing is that personal hygiene products such as diapers and even animal waste can be included in some of these processes, which means that you can expand with wet digestion, you potentially can expand what you put into the unit and basically then how much gas you get coming from it. So typically wet AD, you get more gas than the dry and the plug flow type technologies. Now, co-digestion is kind of interesting because there's a lot of municipalities that say, hey, we've got a wastewater treatment plant. Can we use that to take in organic waste coming from, let's say, food waste or other types of waste? And so we're starting to see more and more applications. And I'll say typically now I've seen in California, there's more and more interest in taking food waste, let's say, incorporating into existing wastewater treatment plants. And so basically then you're looking at possibly eliminating the need to actually purchase or to build a digester. Okay, and next slide, please. And this is a case, this is in Lethbridge, which is in Alberta, where they actually were potentially looking at adding food waste. One of the things that we've seen in these types of projects is you need to consider the amount of waste. And if you don't have a lot of food waste, then any of these projects it's going to be potentially problematic on a financial perspective. So in this case, you're looking at a wastewater treatment plant typically has a lot of water. So the solids are typically in the area of about 5%. And typically in most of these facilities, the gases are flared. But what if you could take that gas, clean it up, and then do something with that gas? So this is kind of the attraction that we're seeing more and more through municipalities in both Canada and the US. Next slide. Now, residential curbside organics. So if you have a program and where you are potentially taking out the organics at the curbside, which one is typically better? So and I've kind of said this already, a wet technology typically creates more biogas. So if biogas is important, and I'll show how it is important, I would say that wet AD may be something you should consider, but it has problems, and it doesn't like leaf and yard waste typically. So the dry systems or dry technologies are typically more amenable to where you actually combine and potentially in your collection leaf and yard waste into the organic stream. And the plug flow is, truly it is considered to be a dry process, but it kind of fits from a technological perspective between wet and the garage style systems. Now, location. This is extremely important. And I've seen projects fail because of a variety of reasons. So one of them is, how close are you to the source of the material? So in the case of a city, you want to be fairly close to where the waste is generated and then transported to a facility. So, and this also feeds into the timing. Like if you have to haul this material for a fairly large distance, it may create a problem because of the timing and because of other things that can result from that, such as odor. On the other end, once you're finished doing your digesting, you have two important aspects to consider. One of them is, what are you going to do with that digestate? Because that digestate has to be hopefully used. I've seen cases where they couldn't find an end market for it and they had to bring it to the landfill, which kind of doesn't make sense. Then you have the biogas that's generated. So if you create biogas and if your aim is to put it into the pipeline, you have to have a pipeline fairly close. And what we're finding is that the cost to build a pipeline, and it's not only the capital cost, it's the time in order to get a permit to get a brand new pipeline installed in order for you to be injected into the system. But in each case, if you're generating RNG and if you want that gas to go into the pipeline, you do have to clean it. And typically, the gas that's generated from anaerobic digestion is typically in the 60 to 65%.
Sit over here.
Disregard that, Peter.
All right. Everybody can hear me?
Yes,
Yep,
we can
okay.
hear you. I think someone was off mute, that's why.
Oh, okay. So, and then the other part of when you generate the biogas, of course, you can create electricity from that biogas and or heat. So the use of that energy that you're creating through the biogas has to be looked at fairly rigorously in order for you to be able to make an assessment whether it's worth it or not. And finally, maybe the most important thing is the proximity to sensitive receptors. So there are typically two aspects that come back to haunt you if you don't do this properly. So one of them is, yeah, you make it an odor issue from the delivery of the organic material and from the actual processing of the material. And if you get a lot of odor problems, the community is not going to be very happy about it. Similarly, you have to consider the amount of traffic that's going to come into this facility, and that would be for the feedstock, and then also for the material that leaves the facility. If there's a lot of truck traffic and it's going by a community, they may not be very happy about that. So this comes back to community engagement, in which Deborah went over. And in my opinion, you have to engage the community early on in the process so that they know what's coming. They can inform whoever is developing this project about their issues. And if you can resolve these issues, you're going to have a community that's going to be much happier about being able to implement an AD technology in their community. Next. So economics. So how does economics have an impact? Well, if you put together a project that is expensive, you may consider, is this really what we want to do? Or will it be somebody else that can do it cheaper? So capital cost is extremely important. As I said, typically we're finding that the dry AD process is typically more expensive and typically generates less gas. Then you have the aspect of operating costs, OPEX. And if you're looking at a project, typically whether it's dry or wet AD, operating costs are somewhat similar, but you're predominantly looking at things like the labor force, how much is the cost of labor, maintenance, and other capital items that may have to be installed during the operation. And then you're looking at revenues. So in my opinion, it's usually a combination of all of these that make a successful project. And typically you want, because a capital cost is going to be money going out, operating cost is money going out, and then the revenues is money coming in. And typically the way we look at it is you do a pro forma over, typically a lifetime of one of these facilities is 15 to 20 years. So you're looking at what kind of revenue you're going to get to offset the negative aspect or the negative flow of money in CapEx and OpEx. So what are we looking at? Typically, you're looking at tipping fees. So you're looking at, for MSW, or municipal solid waste, you're looking at IC&I organics and other potential materials. And actually what we're seeing is that the fee you get from each one of these can be quite different, whether it's wet, dry, whether it comes from a municipality or whether it comes from other sources of organics. Then you're looking at the revenues potentially coming from the RNG and putting it into the pipeline. And I'll talk a little bit more about that. Or, as we're seeing, for instance, in California, electrical revenues are extremely important because they may offset the potential revenues you get from putting gas into the pipeline. So there may be incentives from the utility to create a green type of electricity. And there may be other revenues. The revenue might be from the recycling material that you pull out from some of these organic streams. Next slide. So I'll talk a little bit about RNG and putting methane into the pipeline. So basically, most utilities you're looking at having methane in the area of about 99% consistency. So like I say, biogas, you're starting off with 60 to 65% methane. You want to get rid of all of the non-methane components as much as you can before the utilities, gas utilities, will accept it. So what are the markets? So basically there's three types of markets in the US. So there's the transport fuel market, which is probably dominates. It's the RIN. You have a voluntary market and emerging markets. Voluntary markets typically has a lower, a lower revenue. Transport markets right now are probably the most lucrative. And emerging markets are things that may be coming up, such as hydrogen, and whether you can put hydrogen into the pipelines. And as I said, the most used at this point in time market in the US is the RIN market and possibly the LCFS. LCFS is typically, I believe, you were seeing these types of markets in the western states, Oregon, Washington, and California. What's interesting about the LCFS, and if it can be implemented in the East, is that it's additive. So whatever benefit, financial benefit you get from RIN, you can also add the benefit you get from the local state type programs. Typically for organics, we're looking at what are called D3 and D5. And I'm going to go a little bit on the limb here. I believe D3 is predominantly agricultural material and potentially organics coming from mixed waste. D5 is typically what you might get from doing an anaerobic digestion of food waste coming from a municipality. One of the aspects of RIN is that it relies on daily rates. So whatever it is today may not be what it is tomorrow. It may be higher or maybe lower. And these rates do go up and down. Especially for the LCFS, you're looking at what's the carbon intensity. And Deborah did talk about the impact of taking organic materials and creating, let's say, a methane product, which then will offset the need or the possibility that this material goes into landfill, generates methane. And by the way, that methane has anywhere from a 25 plus impact versus CO2. So the carbon intensity analysis is extremely important. Now, I'm just going to use a number here. What we're seeing is that the value of RNG under the RIN process is virtually 6 to 10 times the price of natural gas. And so at this point in time, and I just took an example, a snapshot a couple of weeks ago, in the US, you're looking at a cost approximately of $32 per MMBTU. Next slide. So we talked a little bit about policy. What I didn't talk about initially is that whatever happens in Canada does have an impact in the US, because you can move the benefits or the carbon benefits from the US to Canada or vice versa. So if there are programs in Canada that are a benefit, they could benefit potential and especially users or potential builders of AD facilities in the northeast of the US. So in Canada, there are basically, there's 2 organic bans in the process. So these are in British Columbia and Quebec. And Ontario is also looking at it, sort of, depending on politics, implementing an organic ban in landfills. But in addition to that, the gas providers in some of these provinces have mandates. And typically, these mandates are to be 5% RNG in the pipeline by 2026 and 20% by 2030. How does that impact on potential projects in the Northeast? Well, because they're going to be hunting for projects potentially in the Northeast. So it does have an impact. One of the things that we're seeing is that more and more that the carbon intensity analysis has an impact on the actual price that you can get in Canada, similar to what we're seeing in some places in the US. But what's of great benefit from the Canada is the fact that you can have a long-term contract. So it's not based on daily rates anymore. You negotiate a rate at the outset, and then you have a contract from 10 to 15 years with these, especially these utilities in Canada. We're also seeing that's not just the utilities that are interested. We're also seeing companies that are interested in buying this material, whether it's through the voluntary market or through a purchase from one of these utilities. As a result, also, you have a lower price. So instead of the $32 per MMBTU, you're seeing approximate prices of $24 per MMBTU coming from the Ontario programs. I think at this point in time, that's going to go up because of this pressure from the utilities to have 5 to 20% by 2030. Next slide. So I'm going to do half this, and then I think I'm going to pass it on to Deborah. So when you're assessing potential projects, in my opinion, and what we're seeing more and more is you have to do really good due diligence. You have to look at the source of the material, the type of material, its proximity, and through that, you have to do a good planning process. So feedstocks are extremely important for the analysis. The type of equipment you use is extremely important. And then for the kind of the final thing, the civil and facility design, including the permitting and its proximity to the potential neighborhood, is extremely important. So with that, I'm going to pass it on to Deborah.
Thank you, Peter. And as Peter said, due diligence and planning is so important. And what we're seeing now in the Northeast and across the nation is a focus on waste reduction. And as I mentioned earlier, a lot of grants are available and have been issued, and states are starting to implement materials management plans. And that does involve looking at organics as a material to manage properly and in developing infrastructure. And as we mentioned throughout our discussion today, stakeholder engagement, community involvement is so important to building out organics infrastructure. And I am just going to go to our next slide, I think. And just to wrap up, there's a variety of anaerobic digestion technologies. And as we see the shift towards organics management, existing facilities, existing solid waste infrastructure should consider how to get involved with managing organics so that it's diverted from landfill and properly reused into a variety of renewable products. There is a growing need for developing infrastructure to service an area. Peter talked about proximity, not only to the generators of the feedstock, but the neighborhood surrounding the type of facility, and leveraging opportunities that are starting to appear. Again, based on the pricing that Peter talked about with renewable natural gas and the potential for projects with utilities. And it is about developing end markets and generating revenue. And just kind of in closing, we look at this as a circular economic opportunity where we can take food waste, food materials that were grown with a lot of different inputs from the growers through to the distributors and the resellers and wholesalers to the consumers, and how do we turn that back into renewable products and energy. So with that, I just want to say thank you. And Peter, if you can turn your video back on, and Megan, if you want to manage some of the chat questions, we'd welcome this.
Yes, thank you so much, Deborah and Peter. That was an extremely informative presentation. So right off the bat, there you go. That answers your question, Bill, on email addresses provided for the presenters. So you can see them right here. And we'll do our best to get through all of the questions that we have coming into the chat. Just starting from the beginning, Bill also asked, and I think this one's for Peter, what is the footprint for a 100-ton per day AD facility, and what percentage of digestate is produced from that 100 tons a day? If you have that data.
Yeah.
I would say if you have 5 acres, it's more than enough. You could probably get away with less. And on the other one, the amount of digestate. So it's all dependent on the type of digestate you produce. So there's kind of two. One is a very dry digestate, so you can actually sort of extract the liquids that are in the digestate, so that you have a drier component. And the actual amount, I can't tell you exactly, because I think it depends on the amount of water that you extract. What's becoming, actually, interestingly, what's becoming more and more used, especially from wet digestion, is the land spreading of liquid digestate, because then you don't have to necessarily store it as long, and you don't have to process it. You don't have to extract the water. Extracting water can be quite expensive. Then the next question is, what are you going to do with that water? And if you take out the water, typically you have to put it through a wastewater treatment plant, because it's still got a lot of organics in it.
Excellent, thank you. And one other from Bill along this similar note, have you ever considered a plant-sized dehydration process versus AD? If so, what are the advantages versus disadvantages?
So,
and I'm not familiar with that, but I don't know if you are.
Yeah, I would say dehydration. I think they're talking about removing of the water, which is kind of in line with what I talked about before.
Okay.
There are benefits of taking out the water. You're going to have probably lower transportation costs, and you will typically, I think, if farmers are the end users of this material, typically they like dry. But then if you convince them that, hey, it doesn't have to be that dry, I mean, can it be wet? And then they sort of say, yeah, maybe, why not? And it might be easier to spread on a farm.
Thank you. From John in Hennepin County, assuming the digestion of identical feedstocks in identical amounts and proportions, why would wet AD generate more biogas than dry AD, both batch and or plug flow?
Yeah, it's a good question. I think it's because the bacteria, through being in a liquid phase, can reach more of the organic materials. It's easier for the bugs to reach the organic materials.
Great. And then I'm going to jump to two that actually came up in our first webinar that was held either last week or the week prior. One is focused on PFAS. So these are coming up again now. And This PFAS question is, does the presence of PFAS in feedstock create any challenges, particularly in the instance of digestate disposal?
I'll start with this one. I don't know if Deborah, you can add on to it. Yeah, PFAS is something that is coming up more. The question of PFAS is coming up more and more. And I am pretty sure that there is PFAS in any of the organic material. In fact, there was a study done, and I believe it was in Australia, where they saw fairly good amount of PFAS in meat. And it depended on the type of animal that you were looking at, whether it was cattle or I think in this case sheep. I think cattle had more on a per density basis. I think there's not enough known about it. What I do know is that a digestion process does change some of the PFAS compounds, but what I've heard is that it goes from one PFAS compound to another PFAS compound. I think it's a question of what is worse or what's more problematic, and I don't think those questions have been answered yet. And Deborah?
Yeah, I can add to that too. I mean, I always like to say, the science is still emerging, and an anaerobic digestion facility is also, if you will, classified as a solid waste facility in any receiver of waste materials, including organics. We like to consider as being passive receivers and not the generators of the PFAS content. So it's so important to look upstream, and if there's an opportunity to talk to, if you have contracts with the different organic feedstocks coming into your facility, it's really important to look upstream and to understand who are the generators. And maybe it makes sense to think about, maybe if there are certain generators that are known PFAS, heavy PFAS users, that you might want to not receive their waste or byproducts from that particular source. I also understand, I think a couple of weeks ago, the EPA had some news out, actually the FDA, it must have been, for halting use of PFAS coating in any type of a food contact package. So that's above and beyond the certified compostable food serviceware items, and this would be just general types of food packaging materials. I don't know when that will be phased out. They usually give the commercial consumer packaged goods a couple of years to kind of run through inventory. But there are steps in place. There are steps in place to reduce PFAS in material streams. Some states are accepting land application of digestates. Other states, I think just one to date, state of Maine prohibits land application of bio-based, or I should say biosolids-based compost. So hopefully there will be continued opportunities to utilize a very nutrient-rich material, digestate from anaerobic digestion, to continue to land apply that for beneficial use.
I'd say in the next probably 5 years, we're going to see much more information on this. And as Deborah said, I think one of the biggest initiatives that's occurring right now is the prevention and production and use of PFAS in products.
Quickly, what state was it again that banned biosolids in land application?
Maine, the state of Maine.
Maine. Thank you. Thank you both. I will do my best. We have 4 minutes. We have 4 other questions. The first one is from Sherry. Do you have community outreach resources that you could recommend that provide BMPs for overcoming common public concerns, myths, and issues related to AD?
Well, Tetra Tech, with our expertise in this area, we do have personnel that can help develop stakeholder outreach programs and best management practices. That's a good question.
Awesome. And so I would say definitely follow up with the Tetra Tech team here, Sherry. How do average AD tipping fees compare with average landfill tipping fees? And then a second follow-up, can you talk a little bit about depackaging? It can be done post-processing. How does that work?
Oh, Peter, do you want to take it and I can back up, or why don't you?
Okay,
Yeah.
I'll start with the depackaging.
And I'll do the landfill tip for you.
Okay. So depackaging, typically what we're seeing is you want to do it on the front end for wet digestion, because it can gum up a digester. And there are some very effective mechanisms to extract, I'll call it the unwanted materials with wet digestion, where you can actually remove the lights, what we call the lights, the plastics and stuff like that. And then the heavies can be stones, metal, and stuff like that. Typically, there are some good technologies to extract those. And then another big one, which I haven't talked about, is grit. And this includes some plastic materials as well. So they have there are technologies available to extract the grit. And so you're left with a fairly clean product that goes into the digestate, which can then be used for land application. In the dry AD systems, and specifically in plug and flow, they don't care. So what you do is you put it into the digester, let's say plug flow, it moves the material. At the very end, you've got all these materials in it, but because you have a fairly dry digestate, you can take that and you can put it through a similar type of technology to extract the unwanted materials. So in both cases, they do it, and the primary driver is what's the quality of the digestate at the end. And I guess really, really important is that you have a process which doesn't plug up in the digesters, because there are digesters that get plugged. If you have to clean a digester, it takes a lot of time and money.
Mm-hmm. And as Peter said, the depackaging can be an upfront pre-processing. And over the years, actually, depackaging equipment has really improved. And some of the technology providers have a screening mechanism that also reduces the issue with microplastics. And that also helps with kind of the grit that Peter had mentioned as well. I think the other portion of that question was regarding AD tip fees compared to landfill tip fees. And, that's a great question. And it really kind of depends on where in the country you're located. Certainly here in the Northeast, we have very high landfill tip fees. In other parts of the country, Michigan and Colorado, landfill tip fees are quite low. And it makes it competitive to implement organics diversion and inciting of whether it's composting or anaerobic digestion. So I always like to emphasize that stakeholders need to be aligned and share the desire to put together comprehensive organics management programs. And the cost of organics, it's not free, whether it's from the curbside collection or from ICI commercial generators through to the anaerobic digesters. There's a cost involved with every point of the handling. So we have to be very mindful that if you want to implement organics diversion, there's a cost involved. And many times, in particular here in the Northeast, it can be depending on the area, it can be either cost, it could be cost effective, and maybe a slightly less fee than disposal and landfill, but don't quote me on that, because there's costs involved with, as we talked about, the capital expense and your operating expenses. There's a lot of moving components. And it does best to conduct a due diligence, which is work that we do at Tetra Tech.
Well, thank you so much. Unfortunately, we weren't able to get to all the questions, but we do have to end. It's 1 minute over. Thank you, Deborah. Thank you, Peter. I encourage everyone who has a question to please reach out to Peter and Deborah with those questions. And we look forward to hopefully seeing you at the next webinar. And please fill out the survey after that you should receive. Thank you.
Thank you.
Thanks.